right, welcome back everyone to Containers from the Couch. Today we have Peter Dalbajan back, and he's going to continue to talk to us about, yeah, see, it's always hard to figure out which way to go, right? He's going to continue to talk to us about Kubeflow. Uh, Peter, last I remember, we left off, we still wanted to talk about pipelines and
Yes.
even using Kubeflow with SageMaker, maybe? Is that
Yeah.
still on the table? Sweet.
Yep.
So it's been long enough. Let's recap real quick. Peter,
Mhm.
by the way, I shouldn't ignore. We should introduce Pavan Mystery, Man of Mystery. Got
Yeah.
it right that time. Uh,
Cool.
Pavan, tell us about yourself. Introduce yourself in case we have some new viewers today.
Yeah, we have a new viewer waiting. Swarnaditya Maiti. Yeah. So welcome, and just a bit about myself. Thanks, Brent. Hello, Peter. Welcome to the show again. You had a different host with Mustache last week, but uh, this week it's someone who is follically challenged. So yeah. so so
That's right.
I'm Pavan Mystery. I'm a special. I'm a developer advocate with our container services team, and been with AWS for nearly 6 years and doing security. So I'm specializing in security related topics within container services, which is it's quite interesting. So earlier this week we covered a few topics, and today we are back with Peter on Kubeflow, which was the main topic last week. So if you missed any of the videos on Kubeflow, do go check out Brent's YouTube channel, where we have all the recordings up, and we also share it on Twitter as well. So take a look for context. But today we are excited to take a look back at Kubeflow again and see how we can integrate or work with SageMaker.
And we do have a returning viewer. Before we even went live, waiting, come fast. And then, I think cheerleading. I'm not sure if that's what that's supposed to be, but I'm pretty sure it's good. And then they remembered that we had a fairing issue
Yeah.
with the last show, but we ended up addressing that and fixing it, if I remember correctly. And then
Yeah. Let me
not
address that real quick. So we're in the middle of, when I say we, Kubeflow community is in the middle of a newer release. So if you've been keeping up to date on daily activities that Kubeflow is doing, Kubeflow is moving from 1.0.x version, I think 0.2, to 1.1, which is a major release, right? And as we were migrating, we have some issues that you'll see in fairing. So the version of Docker container, Docker image that we used as a notebook server, that will apply to Kubeflow 1.1. So I was, very eager to try and test that out. Um, so that version doesn't work with the fairing notebook. I think that still has an issue, but we're going to go and take care of that. So if you're seeing this in the future, this issue that we are talking about in terms of fairing is going to be resolved.
nice. And then NetHole, welcome back, NetHole, by the way. Uh, just dropping it here. Hopefully, someone will recognize that the AWS SageMaker machine learning samples will no longer run because of the upstream dependency changes. There are a bazillion of issues, yet the coding repositories haven't been updated. Do you think we're going to run into any issues like that today?
So if you use the version of EKS Workshop, it works. We're going to use the version that we have from EKS Workshop. I made sure that works because I didn't want it to have the same problem that we had with fairing last week. So what I would do is, and I'll talk about the version that NetHold is talking about. So there is another set of artifacts that the SageMaker team has. And we are going to catch up in terms of EKS Workshop, and I'll talk about those differences and what we'll do in order to catch up as well as we go through that.
Perfect. Awesome.
Right.
All right. Let's get down to it. Let's see.
Share
We
the
gotta.
screen.
That's what we gotta do. We gotta share the screen. Let's kick this couch out of the way and get over to our screen share. Bam.
Cool. So what I did, so if there are newer folks who are joining this one, I'll just take 1 minute in order to walk through. So if you go to eksworkshop.com under advanced, we have all the content of Kubeflow. We've already added the YouTube session that we did last week with Brent, myself, and Adam here. So you can check out this YouTube tutorial. During that session, we went through the installation part. And then after that, we went through opening the dashboard, taking a look at Kubeflow features. We then looked at Notebook and ran a sample model from the Notebook. And then we did training and inference through Kubernetes. We did that. And then we did fairing session. That was the last session that we did, right? Real quick catch up. Today, we're going to focus on Kubeflow pipeline, and we're going to wrap up the whole Kubeflow session right here. So before I go to Kubeflow pipeline, I did open the dashboard. So if you guys are familiar, this is a Kubeflow dashboard.
Yep.
We'll go to notebook servers. We're on the namespace that we created, right? EKS Workshop, and we have 2 notebooks there. The one that we're going to use is this one, which is the latest one. So I'll keep this open. So let's go to the tutorial. There are a few prerequisites that we need to do. And most of them are in terms of handling IAM permissions, right? So this chapter, and you'll see this exercise that we do, as we go into the learning mode on each of the chapters, we'll go and do some IAM wiring, right? We'll do them before, so that the things that we are doing, the resources that we create, we have those IAM permissions. Once we're done with those, we tear those apart, right? So we remove those IAM permissions. Yeah. But there is one caveat here. We do give full permissions, and we highlight that in the chapters as well. So if you're an enterprise user, take this as a learning experience. You may want to do this in your dev environment just to see how things work. But as you go into production, you do want to put fine-grained access controlled, so that if you're giving access to S3, make sure you only have permissions to like read permissions, write permissions to a specific bucket, not the entire S3, right? So you do want to take care of those things.
Yeah.
All right.
Sure.
So
that's a good call out.
Yeah. So here in the prerequisites, what we will do is we will do 3 steps, 3 levels of IAM permissions handling. The first one is we will use AWS secret, which is, we create a secret in Kubernetes. We name that as AWS-secret. And in that, we will take the API keys that are generated. We basically will create an IAM user called Sagemaker user, grab the API keys for that user, and then store that API secrets as AWS secret. That's the first thing we'll do. So let me walk through the IAM permissions, and I'll go back to the comment that the user posted earlier that the Sagemaker has a different approach. So that's the first thing we'll do. The second thing that we will do is create an IAM execution rule for Sagemaker. So these are things what we will do for Sagemaker side of the house, right? So first thing we did was when you take API actions against Sagemaker, that is what that AWS-secret is going to do, right? The second permission is what is Sagemaker going to do when it tries to do API level functions. So that's the second IAM permissions that we need to assign. The last one is is SageMaker invoke endpoint, and this comes at the very end of the chapter, where once we go and create a pipeline using Kubeflow pipeline, we send actions to SageMaker saying, "Hey, SageMaker, go and run these training jobs, right? Create these models for me." And then we will say, "Create an inference endpoint for me," right? Once all of that is created, then we will go and run inference from our Cloud9 to SageMaker endpoint, and that's what that last permissions come into, where
Right.
you basically say who can make invokes to those inference.
So Peter, I had a question around the secrets with the access keys being stored in the AWS secret object. In March, we announced a feature called Secrets Encryption, which allows customers to encrypt their secret store, as in secrets within Kubernetes. So if I'm a customer who has enabled that secrets encryption feature, will there be any impact on using this, or it will be the same for the user? I mean, would the users see any impact on their operations?
Yeah, so great question. So correct me if I'm wrong. I know you're deep in security there, but this is
Lots of secrets.
There's a lot of secrets. This is my understanding. So the capability that we enabled is the secrets that you generate, or the objects that get stored on etcd. That content is backed by a KMS key that is now controlled by customer, right?
Yes.
So you have a chain of commands that the customer can do. When they go and create an EKS cluster, they can go and say, "Here's the key that I want to use. Use that key to encrypt all of the content that you store on etcd servers on the control plane." So everything is encrypted using that KMS key. Now, none of the other personnel can access your etcd environment unless you have that kind of that key, right?
Yeah.
Now, coming back to secrets, if you have API permissions, right? If you're a cloud admin, if you have permissions to access secrets, then you can see those secret environment. I think that is still true. So you do want to make sure that you secure that wheelhouse.
And Techie Stories asked, by the way, welcome back, Techie Stories. Good to see you again. So these are service level permissions. And I think that kind of went into what you were describing, how we're creating what amount to user level permissions first, but then don't we also grant permissions for SageMaker to run stuff on our behalf as well? Isn't that part of what you're going to build out here as well?
Yeah. So that is the second permission that we are creating. So the first one is this one, which we will do now. First one is Kubernetes to do API actions against SageMaker so that we can call SageMaker APIs, right?
Yeah.
The second one is the IAM execution role so that SageMaker can do things like, if it needs to access S3 in order to store a model. So those are all IAM permissions that SageMaker needs. So that's the second permissions that we're going to do.
Yeah. So that's like cross-service permissions almost. Or maybe not even almost. That's what it is. So yeah, hopefully that answers the question, Techie Stories.
Cool. Now, the distinction between this approach that we have and the artifacts as SageMaker, if you go to GitHub I think it's in Kubeflow pipeline, they're maintaining a set of samples. If you follow those, we made a bump. We made an improvement, which is a good improvement. And what we did there was we got rid of this AWS secret, right? We made use of IAM role for service account. And that is the next version you can imagine of this chapter that it's going to look like. So we're going to add that capability as we move towards improving this chapter. So we got rid of AWS secret. We make use of IAM role for service account in the SageMaker notebooks, SageMaker artifacts that are stored in GitHub. So, you can read that. There's a README that goes into the details on how to take advantage of IAM role for service account. So, the service account that we use in the notebook that the Jupyter notebook assumes, only that service account has access to resources that are called that they use on SageMaker.
Yeah. And that's something, by the way, Pavan, correct me if I'm wrong, we haven't covered that yet. We've only talked about it, right? And we still plan to do a show on IAM roles for service accounts?
Yes, yeah, so that's right, Brent. So IAM role for service account, we haven't discussed in depth, and we're planning to do it next week, I think. Yeah, that's up next week.
Perfect. Awesome.
Cool. So let's go ahead and take care of these things, and then we can move on to what we need to do after these IAM permissions have been handled. So I'm going to close this one. We don't need that. Leave the other one open. And run the first 3 commands. So we have our secret keys in a folder there. Now we will run the next 2 commands in order to create that AWS secret. Okay. So now if I do kubectl get secret /AWS secret in Kubeflow namespace, I should have that. I should have that there. Just created that.
Cool.
So now let's take care of the other 2 permissions. So the second one is we're going to create a role. This is the role that we're going to use in order to force SageMaker to do its things. Okay.
Awesome.
And you do want to keep this role handy. So remember to come back to this one, because this is what we need to replace or use this role when we run the notebook itself. So that's the second one. And then the last one is, and we talk about that, make sure you make a note of that role. And the last one is this one, which is once we have an inference, we give permissions to our Jupyter notebook, or essentially the notebook that is running on a worker node. That's this worker node, right? IAM role that is attached to the worker node. We give that SageMaker invoke policy. All right, so once that is done, we took care of all the IAM side of the house. Hopefully all of that makes sense. Now we're going to go to the notebook and just keep running those cells over there. So here's the notebook. So we've got all these different services there. And the SageMaker one is this one.
Mm-hmm.
So we'll open that. Okay. And yeah, so what I will do here is I'll just go and say kernel restart and run all, which is It's going to run all the cells, right? So we don't have to. Oh, actually, before I do that, yeah, because we won't be able to do the invoke, so that's not a good approach. Sorry about that. So let's run one. Let's run one by one, because that's not going. Because you do have to go and replace some of the like IAM roles. You have to update them. So let's do. So that was the first cell. Let's now go ahead and run the second cell. So here we're creating a bucket, S3 bucket, right?
Mm-hmm.
And the only minor change that I did from the version that you'll see from GitHub is I just changed these range to 3 because
it was what, 100 or something, wasn't it?
It was 16. So it had 16 variation of ASCII characters and 16 variation of numbers. So I just minimized it to 3 and 3. So that's why you see smaller S3 bucket there. So that's that. Now here, what we will do is we'll prepare the data set. So let's go ahead and run this one. Okay, it says the training data is uploaded. Now we've already done these things. So if you start from the notebook, you have all the relevant information there. Now we're going to run the next cells. So that is one where we're going to import KFP client SDK. And here's the important one. So the Sagemaker components, right? This is what tells Kubeflow pipeline how to work with Sagemaker, right? So this is the integration that we've done between Kubeflow pipeline and Sagemaker. So essentially what, if you go take a look at the GitHub there, what we do is we bring in all of the Sagemaker definitions, and we'll see those over here in the bottom line of the code. We bring in all of those as objects into Kubernetes, right? So that now you can use them natively in Kubernetes.
And Peter, real quick, Techie Stories asked, can you give a GitHub link to the repo? I think she's talking about the repo where the notebook that you opened exists.
Yes, absolutely. Good question. So the link to the repo and all of the examples that are stored are part of the fairing chapter. So if you go through the notebook, go through them sequentially, and this is where we have where we say clone this repo. Yeah. Right. So you can find that link over there.
Perfect.
Sure. Okay. So here's where we're going to replace the Sagemaker role that we just created. Which is this one. And I ran this notebook earlier this morning because this execution end-to-end takes about 45 minutes. It's quite long. So what we can do is we can let it run, and then we can go back to the previous run so that we'll see how the end result looks like. Okay. So that's the only thing that you have to do. You have to replace that Sagemaker role. Now Sagemaker has permissions, and run that. And in the next two commands, what we'll do is we'll compile all of the information that we've given. So run that, and then now we go and submit using a KFP client, right? So using Kubeflow pipeline SDK, we took all the information that was available in the SDK, and we submitted that one. So what I'll do is I'll open. I mean, you can open both of these. This was the first link. I'll show you how this looks. So this was the first link, which shows experiments. Experiments is how you group your runs, right? So you might have, experiments is, you can think of like projects, machine learning experiments. So here we created an experiment named AWS. This was the one run that I did earlier this morning. This is the second one that we are doing. And if you click on this, which is essentially this one, so I'll close this. This is the actual run that is happening right now. So if you click here, you'll see all the information like input, output that has been given through Kubeflow pipeline, any volumes that are in use. Currently, we don't have anything, any manifest, and then the logs, right? So this is where it actually shows. So you'll see a log view of how things are progressing. So this is the log that is coming from Sagemaker, right? Mm-hmm. And there's a link here where you can go and look at a hyperparameter job that is being run on Sagemaker. So we'll go take a look at that. But before that, let me explain what we just did, right? A quick recap, because I know I went pop up right there from the beginning. So if you see this notebook, so this is we're using k-means machine learning algorithm in order to process MNIST classification, right? So MNIST is our images. Those are numbers. There's about 60,000 images that are available in the MNIST dataset. And we're using k-means. If you're a machine learning engineer, you'll probably know this better than me. So k-means is a way to, I want to be honest, I'm not a machine learning engineer.
Yeah, I'm not either.
Yeah. So k-means is a way to cluster or group a set of properties, right? So you can identify, as the data has been spread out in your graph, you can say this cluster, you can identify that saying this cluster belongs to certain category, and that's how you can classify, right? Based on clusters of data. And then you can create means, and you can say the best mean that is available. I'm guessing that's what that algorithm does.
And then you mentioned hyperparameter on SageMaker. Is hyperparameter like where it just tries out every possible permutation of different options and analyzes each result to figure? So it's like if there's 5 different variables that all have a set of random number of different choices, it goes and it tries out each individual one individually and brings back the result to figure out what is the best possible combination of options. Is that close to being right, or am I completely off in left field?
So I think what hyperparameter tuning does is it makes your model better, right? And it finds the best values that you need for running your jobs. So if you look here, we've given certain parameters for HPO, right, for hyperparameter tuning. You'll see there's we're saying run this hyperparameter tuning job 9 times. That's the maximum number of times that this job can run. And then run them 2 in parallel. So we're saying we're running 2 of those. And we'll go take a look at the SageMaker console to reflect all of this. We've given some sizing on the infrastructure side, like use P3 instance, use only 1 instance, 50 GB in volume. So we've given all of those, but that's what it does, right? So you find the best value that falls in the middle, that gives you an optimized way of saying, this is how your model is tuned. So there is if you're doing this in Kubeflow, there is a feature called Katib that is known for doing hyperparameter tuning. In this case, we're making use of SageMaker because SageMaker provides it gives you all of these capabilities, right? And I'll show you how easy it is if you start using those SageMaker type of APIs in order to do these functions.
Okay, cool.
Yeah. But
NetHole
yeah, you do have to provide these parameters. Like we're providing k is the value of k and the value of feature dim. So we do have to provide some of these parameters in order to find that right value.
NetHole also let me know, by the way, that that would be the optimization of hyperparameters, and that yes, I'm out in left field. So yeah, I said that's basically my home away from home, so I'm used to it.
Okay, so this was the algorithm, right? So so we're running a few hyperparameter jobs. That's this first block, and then this is how we submit to SageMaker, and then we go and run the training jobs. Then we create a model, and then we say, let's go and expose this as an inference to make prediction, and we make use of batch transformation, which is a capability of SageMaker, in order to make that inference available, endpoint available. So let's go back to SageMaker, Kubeflow pipeline console. So you'll see this is the first one that was running, right? The hyperparameter tuning job, and the job is still running. So now you can click on this link here to go to SageMaker. And the console is loading up.
So whilst that's happening, Peter, I mean, in the previous window, you had secrets attached to your commands to run as well. The AWS secret, which was created initially. How does so what's the use there? Is it pulling the secret from Kubernetes secrets and then running it within
So
the
this
cluster?
is it's using the secret. So Kubeflow pipeline is using this secret in order to run API functions against SageMaker.
And
Right?
that's a secret object in Kubernetes, right? Okay,
That we just created earlier.
right.
Right.
Okay.
Okay. So it has the right permissions and it can
Yep.
run it in SageMaker.
Yeah, we gave SageMaker full access.
Yeah.
So, so that was that was what we did earlier in the chapter. The other permission that we gave here, we plugged that in, is this role. It's yeah, this one. This is what SageMaker is going to use in order to execute.
Right. Cool.
Sure.
Thanks.
So here's the SageMaker console. You'll see it's completed 4 of those 9 jobs. 2 are still progressing. It runs 2 in parallel. Remember I showed earlier. So you can see those over here. You can see training job definition. You can also go and take a look at the configuration. Here's where you can see maximum number of training jobs as 9, run 2 in parallel. So basically what we submitted over there, you can reflect this. You can think of, if we've taken all of these objects, each of these configuration parameters, pushed it as SageMaker components, and now you can use that in Kubeflow pipeline in order to have that seamless submission.
Nice. And Techie Stories is still trying to help me out. Tuning is basically filtering out the outliers. Is that a fair assessment?
Yeah. Like I was saying, I'm not I'm not a machine learning engineer. So if you know the definition there, feel free to go for it. I'm still learning.
Me too.
And here you can see all of those training jobs, right? So all of the hyperparameter training jobs that we submitted, you can see them over here. So this, like I was saying, this is going to take some time. And what we'll do is we'll let it complete. It's going to take about 30-45 minutes. What we can do is we can go to our initial experiment. Go look at the one that we ran this morning. So here, how it's going to look like when it completes. Right, job completed. After that, it goes and runs the training job, and it creates a model. It pushes that artifact model into our S3 repository. Then it creates an inference. An inference has 2 steps. One is it creates a batch transformation, and then deploying the model as an inference endpoint. So if you look here, it creates an inference endpoint. It gives us the inference endpoint ID there, and a batch transformation is essentially taking a data set, checking if the inference works, and you can use batch transformation as well for your inference.
That looks like this inference endpoint is out on SageMaker.
Yep, everything is happening on SageMaker right now, right?
Is it possible, and would anyone, again, this may be crazy talk, is it possible to use SageMaker to build the inference, but then deploy the inference endpoint back into my cluster?
In other words, you train the model in SageMaker and run inference on Kubernetes?
Yeah, use SageMaker for its vast capacity and capabilities, but then once it's trained, maybe you don't want to keep something up and running on SageMaker. You might want low latency, to
Yeah.
have your workload, have your endpoint running right alongside your workloads.
Yeah. So yes, you can certainly do that. You can. So you'll see here we've got 5 steps, right? Each of those steps can, they can run as a modular fashion. You can run them on Kubernetes, you can run them on SageMaker, and you can interchange them as well, right? So you can use Kubernetes in order to train your job. You can maybe have Kubeflow pipeline running on your laptop. You can train the model, so you have the best model that is working for your application for prediction. And you can use SageMaker for inference. So you can go and just say, hey, SageMaker, go and run this inference and run it using, the best, least capacity, or like, like on spot or something like that. You can do the same thing for training your jobs as well, because they have an API where you can go and say, run training jobs on spot so that you can best cost based training, and you can run it efficiently as well.
Cool. That's really cool.
Yep. So this is what we've got. So once the other run that we initiated, goes through, you're going to get an endpoint like this. What we're going to need is this ID, endpoint ID, and you can get this from SageMaker console as well. So if you go to console, you're at the training jobs. You can go to endpoints under inference, and you'll see that same endpoint here. So what we'll do is we'll come back to our notebook. We've got everything done, all the run executed against SageMaker. And the last part is the prediction, right? So you created your model, you got your inference. Does it really work? So what we need to do is we need to replace this. I think this is the same ID that I created earlier in the morning. Yeah. So we can take this endpoint and then we can just run this to get predictions. So yeah, this is the expected result. So if you're using k-means, it gives you distance to the cluster, the grouping, and the closest cluster. So that gives you that your model that you created using SageMaker is good, and you can go about running this in production. So yeah, that was it. That's this SageMaker integration that we have. Let me go back and take a look at how far we've done here. I think this is the longest one. It does take some time.
Yeah, you mentioned like 45 minutes or something.
Yeah.
And I know we didn't get started till about half after, so probably has a ways to go. I guess it's been going for 15 minutes, it says.
Yeah.
Oh, but the total was 18.
Yeah, for this one, for HPO tuning jobs, it's about 18, 20 minutes. After that, we have 3 other steps.
Oh, okay, gotcha.
Those will take some more time as well.
So Techie Stories does ask, and you may not know this, but just in case, I wonder, would this work in Unreal Engine APIs as well when built in AWS?
Yeah, I'm not sure.
I'm not familiar enough with Unreal Engines either to know, how that all fits in. But if you have more details or more context, feel free to add that in the chat.
Is that the gaming service that Epic Games have open source?
I don't know if that's it rings a bell as a gaming service to me, but I don't know if the details about if it's open sourced or not. I haven't kept up in a few years in the gaming world, and Techie Stories says yes, so yeah,
okay,
you must be right. All right. Should we wait around and see this finish, or should we just look at since we saw the completed one that you did earlier,
Yep.
What do you think?
Yeah, I mean, we can let this keep running. We can talk, if there's any questions, we can talk about those. We can answer those questions. But yeah, this is going to take some time.
Is there anything worth looking at while we're waiting in the GitHub repo? Is there anything worth looking at to see, what the Sagemaker team may have put out as far as samples goes and stuff like that? Is there, maybe we could tour around that for a minute or two and see what's out there to experiment with.
Yeah, good. Let me take a look. All right, so I just did a search for Kubeflow pipeline Sagemaker GitHub. So hopefully we'll pull up pipeline components. That sounds about right. So let's open this up.
I had a question, Peter. Like, whilst we're doing this, so when you mentioned the endpoint, the end result which we got at the end, you had a link with endpoint. Is that where we can submit, let's say, some of the examples or samples, and the machine learning sort of that algorithm would give us the result? Is that something what's expected? I'm a totally newbie here, so
no worries.
Endpoint.
Yeah.
So sorry, go ahead.
Yeah. So the endpoint that we have, right? So think of this is what your application does. This is your application, right? Essentially, this is nothing but the training model that you just created, right? Using Sagemaker, and it is backed by a load balancer, and it does serve RESTful APIs. So very much similar to the microservices, like a web service that you same type of approach, right? Now, what we do with web services, we send RESTful APIs saying, get request, pull, put request, those type of post requests, right? With these, you have to use the JSON, send it the data, right? And say it could be like an image that you would send, right? So you take that JSON blob and send that to the endpoint, and say, and the endpoint is going to respond, and it's going to give you predictions. So the request that you do is basically asking, is this image, if it is an image classifier model that you just built in a model, is this image a cat or a dog, like we spoke about in our last sessions, right?
Yeah.
Or is this image, because this is an MNIST one, is this image number 6 or number 7, right? And it can give you a response saying this is 90%, the machine will say this is 90% 6. And it can say those values as well.
Great. Yeah. Yeah, I mean, that was my understanding. I just wanted to confirm that that's what's happening. Like, we are tuning and then training and then creating an endpoint with that model, right? So makes sense now. Thanks.
Yep, absolutely. So here's the repo that we have for Sagemaker components. We used the same version or the previous version of Sagemaker components in our Kubeflow workshop. And if you want to go look at the latest one, you can read all of the information here. And I think, let me see. So there is a document that they mention, end-to-end, maybe this one. Let's take a look. So there's a good documentation here if you want to go and use this Sagemaker components. It's this one. So here we talk about the role for service account, which I was talking about earlier, right? So this is a recommended approach. This is what they're using. So if you try out this instruction, go with the instructions that are available in this repo. Because the same thing is not going to work with workshop model, because workshop we use AWS secret, the secret that we generate in Kubernetes, right? But if you follow this method using OIDC and using IAM role for service account to get granular permissions, all you need to do is in the Python code. Let me go back here. In the while you submit these jobs, you just have to go and comment this out, right? So because you're not going to be using those secrets as you submit them.
And last I remember we talked about this. The problem wasn't Ursa directly, it was the version of SDK that the older containers were built with that couldn't take advantage of Ursa. So now they've revved the SDK that they include, and they can use the fine-grained IAM roles for service accounts. Kind of along the same lines, NetHole asks, do they indicate how to use the older containers so that taking the entries from GitHub can be successfully used, given that latest isn't happy at the moment? Do you have any experience with pinning to a specific container version to do that, or do you see people using latest, even in production?
Now, I would certainly make sure that you pin to a particular version. Actually, with this, let's go take a look here in the notebook, and make sure that you do that every time, right? Mm-hmm. If you see here the components version that we're using, it's pinned to a particular commit.
Yeah.
Right. If you use the latest, it's not going to work because the latest uses the IAM role for service account, and each of these projects are they're open source and they run independently. There's just too many levers, so I would make sure that you use a particular commit in pretty much everything.
Yeah.
Same thing over here as well in the SDK. We make use of a certain version of KFP SDK, which is 0129, and we make it clear if you use the latest, it's not going to work. So be careful there.
Awesome. And you hit the nail on the head. He says, bingo, thank you. That pinning for particular commits is what he was looking for.
All right, great, awesome. So I was going to go back to, I think, let me see here. Yeah, so we were talking about, so we do have that information where we want to walk towards enabling IAM role for service account for all of the use cases that are applicable to Kubeflow. And we talk about that in our Kubeflow documentation, Kubeflow AWS pipeline. If you want to track progress, there is an issue that highlights what, where are the improvements that we need to make. You can check those out and, +1 them so that we know that this is important and we can work on it.
Nice. All right. Well, thank you for joining us and walking us through Kubeflow pipelines.
Absolutely. Looks like it's almost finished, but yeah, absolutely.
Cool.
Glad to be here.
Yeah, absolutely. All right. So if you're familiar with the show, today is our Friday. So this is going to be it for us for the week, and we'll be back on Monday. And if you're familiar with the show, you probably are familiar with how we don't really plan things out too far in advance. We try and keep things relatively loose because we want to be able to take requests. That said, we have planned out already a couple of shows in advance. So next week we are going to bring on another developer advocate and introduce him to the crowd, and he's going to walk us through on Monday the very, very basics of just getting started with Docker and container images, and walk us through super beginner level stuff. Then on Tuesday, Pavan is going to walk us through. I think Pavan, is it Pavan that's going to do this? Or is it Michael? Either way, Pavan's going to be there and Michael is going to be there. So you'll get to meet 2 more developer advocates next week. And Michael's going to walk us through IAM roles for service accounts. So,
Yes.
we've touched on that a few different shows, and we've really talked a lot about it today. So hopefully we can fill in any blanks there, and we can actually talk about just that mechanism and how it works, and we'll see it in action and stuff like that. On Wednesday, Adam, who will be back next week, by the way, is going to show off blue-green deployments on ECS. And then on Thursday, we'll have a guest from Docker come on and show us the Docker ECS integration. So we'll be able to see that demoed live and talk to one of the folks from Docker about that project. So that's the plan for next week. If you have any show ideas, tweet them to us, Brent Contained or at 98 p.m. for Pavan. And you can also tweet Adam at real Adam J. Keller. And we will get your shows onto the list and start working on them. So until next week, I really appreciate all the chat, all the activity, and hope to see you again. Oh, go ahead.
Just one more thing. We have Containers Day, 17th August 2020, and here's a link which is down below, so you can click there and join us if you can. That'd be a good event to keep up to date with our announcements, some releases and updates, meet our team behind the scenes, and ask questions. So do join us.
Yeah, awesome. All right, thanks everyone.
Thanks, everyone.